Good afternoon, students. I'll teach today definite integral as a limit of a sum. Okay, very important chapter is there. So note it down. And definite integral as a limit of a sum. I'll discuss now. Okay. Solving the integration, no problem is there. Okay. Suppose writing say suppose 0 to 1. Suppose x dx writing. So this is lower limit, this is upper limit. Okay. Simple integration, as you know, suppose x square by 2. So write 0 to 1, that is 1 by 2 minus 0 by 2. So 1 by 2 is there. Okay. So one statement is there, right? Fundamental theorem of integral calculus. Okay. Fundamental theorem of integral calculus. If fx be single valued and continuous function in the finite closed interval AB, then there exists a new function, suppose phi x, such that phi dot x equal to fx. Then integration a to b f of x dx equal to phi b minus phi a. Okay, I am writing the statement. Okay, I am writing the statement. See, fundamental theorem of integral calculus. Okay, if fx be single valued and continuous function in the finite closed interval AB, then there exists a new function. There exists new function phi x, such that phi dot x equal to f of x. Phi dot x equal to f of x. Okay. Then integration a to b fx dx equal to phi b minus phi a. Here a is lower limit and b is upper limit. So 0 to 1 x dx. As usual, you know the formula, that is integration, that is x square by 2. So 0 to 1. Here upper limit first you put, in place of x equal to 1 put 1 by 2, then minus a lower limit. Okay, this is 0 by 2. Okay, so this is very important theory is there. Okay, with the help of a to b fx dx equal to phi b minus phi a, we have to solve. Okay, and suppose I am giving one sum. See, I am writing, say integration 1 to 2. 1 minute, wait. So right, integration 1 to 2, 1 to 2, x4 plus x square plus x dx. Okay, simple formula is there, right? x5 by 5 plus x cube by 3 plus x square by 2. Okay, right, 1 to 2. Now write 2 to the power 5 by 5 plus 2 cube by 3 plus 2 square by 2. Okay, minus 1 by 5 plus 1 by 3 plus 1 by 2. So will be here 32 by 5 plus 8 by 3 plus 4 by 2. Okay, minus 1 by 5 minus 1 by 3 minus 1 by 2. So write this by this, it will be 31 by 5 plus 7 by 3 plus 3 by 2. Okay, just a simplify, you will get the result. So 5 3 2 LCM will be 30. Okay, this will be 30. 5 6, there is 6 80 plus 3 10 70 plus 2 15 45. Now here so 6 5 11 5 so 3 by 30. And this is the answer, right? Okay, understood? Simple formula. Again I am showing 1 minute. Say suppose zero to pi by 2, suppose sine square x dx. Okay, simple integration, suppose 0 to pi by 2, we can get a half of 2 sine square x dx. Now write half, take outside 0 to pi by 2, 1 minus cos 2x dx. Okay, so write half. So this will be x integration dx x minus sine 2x by 2, 0 to pi by 2. Okay, so write half. This will be pi by 2 minus sine 2 pi by 2, that is sine pi by 2. At 0 will be or 0. If you put lower limit, the value will be 0. Okay, so answer will be pi by 4. Understood? Again, suppose 2 to 3, 2 to 3 e to the power 4x dx. Simple integration, write e to the power 4x by 4 integration 2 to 3. Okay, so e to the power 12 by 4 minus e to the power 8 by 4. This is the answer. Okay, all of you understood? Suppose I am doing integration 1 to 2 log x dx. So log x we will do by parts. Okay, all of you know by parts method. Okay, now I am showing, see, let I equal to, consider I equal to, right, log x dx. Okay, now write we can write log x into 1 dx. So write log x integration dx minus ddx log x integration dx whole of dx. Okay, now x log x minus dt log is 1 by x into x whole dx. So write x log x minus this is cancelled, so x. Okay, we are not constant here. Constant c is not equal. Okay, this is bounded function and the limit is given, lower limit to upper limit. Okay, so we will not add any constant terms. Okay, now I am writing see the value of this integral. Okay. Now right, so this is coming x log x minus x, right? 1 to 2. Okay, so right 2 log 2 minus 2 minus 1 log 1 minus 1, and log 1 all of you know value will be 0. The value of log 1 will be 0. So right 2 log 2 minus 2, here this is 0 plus 1. So right 2 log 2 minus 1. Okay, so write log 4 minus this you can write log e. All of you know the value of log e will be 1, so it will be log 4 by e. This is the answer, log 4 by e. Okay, next one, see. Okay, see. Right. Suppose integration a to b, okay, sine 2x by a sine square x plus b cos square x dx. Okay, so you write here let a sine square x plus b cos square x equal to z. You have to write first. Then a 2a sin x. So again cos x here minus b 2b cos x and ddx cos x sin x. Whole dx side it will be dz. So you can write here a, this is sin 2x minus b sin 2x. Okay, dx will be dz. So you can write here a minus b sin 2x dx will be dz. So sin 2x dx we can write dz by a minus b. Okay, understood? So right Okay, listen. So here now this will be, so right here 0 to, I think not a by b. Okay, 0 to pi by 2, right? Okay, 0 to pi by 2. If x will be 0, see here x and write z. Okay, if x will be 0, you put x equal to 0. This part will be 0, cos 0 1, so z will be b. Okay, and if x equal to pi by 2, so sine 90 degree 1, so a, this will be 0. Okay, so this part will be a. So right, the limit 0, then b. Here b, here is a. And sine 2x dx will be dz by a minus b. And this part you have to consider z. So write z. So 1 by a minus b log of z. So write here b to a. Limit already changed. So it will be 1 by a minus b log, right, a minus log b. So you can write 1 by a minus b log a by b. Okay, this answer is there. Okay, see. Next one again. Okay, now definite integral, one form, another formula is there, limiting value. Okay, of definite integral. So one formula is that, remember, that is first principle formula, a to b f of x dx equal to, we know limit h tends to 0, h summation of r equal to 1 to n f of a plus r h. I will discuss this formula. Okay, h tends to 0, h summation r equal to 1 to n f of a plus r h, where n is equal to, right, b minus a, n h equal to b minus a. Okay, also you have to write here r equal to 0. This formula you can write also, limit h tends to 0, h summation r equal to 0 to n minus 1 f of a plus rh. Okay, suppose I am doing, look at here, this is the first principle of definite integral. Okay, a is the lower limit, b is the upper limit. Suppose you are doing 0 to 1, suppose x dx, we know x square by 2. Okay, so 0 to 1, that is half answer we know. With the help of the formula, this one, how to solve. So first write here, writing f of x, right, x. So f of a plus rh, right, a plus rh. Here a will be 0, b will be 1. So right will be RH. Here A equal to 0, right? B equal to 1. So we can write NH B minus A. This is 1. NH, the difference 1. F of A plus RH equal to A plus RH. Now using the formula you can write, see, so 0 to 1 x dx. So you can limit h tends to 0, h summation r equal to 1 to n. F of A plus RH is 0, so F of RH, so it will be only RH. Okay, just we put here F of A plus RH is 0, so RH. So limit h tends to 0, h. So write 1 into h plus 2 into h plus 3 into h up to n into h. So limit h tends to 0, h is square, right? 1 plus 2 plus 3 up to n. So limit h tends to 0, h is square. All of you know GP formula, AP formula 1, 2, 3, that is n into n plus 1 by 2, 1 square, 2 square, 3 square, up to n square, n into n plus 1, 2n plus 1 by 6. All of you know? Yes. So right, h is square, n into n plus 1 by 2. So right here, limit h tends to 0. Okay. So right, nh plus h by 2. Okay. Now you put the value of nh, you know, 1. Just you put 1 into 1 plus h by 2. So right, limit h tends to 0, 1 plus h by 2. Now put h equal to 0, so it will be 1 by 2. See, answer is coming 1 by 2. Same. If in question paper is given with the help of first principle, find the integral value of 0 to 1 x dx, then you can do this process. Okay. Otherwise, just simple methods, 0 to 1 x dx equal to simple formula you can apply, that is previous I'm discussing this one, that is fundamental theorem of integral calculus. Okay. See. Similar way you have to do, suppose with the help of first principle, right? 0 to 1 x square dx, okay, and 0 to 1 x cube dx, okay, 0 to 1 x square dx, 0 to 1 x cube dx. 1 minute. Similar process you have to do, okay. Suppose I am doing 0 to 1, suppose e to the power x dx. Okay, similar process, right? Here f of x, right? E to the power x, f of a plus rh. So e to the power a plus rh. So a0, so e to the power rh, right? So limit formula, right? H tends to 0, h summation r equal to 1 to n f of a plus rh. First write the first formula, okay? So limit h tends to 0, h summation r equal to 1 to n. So right here e to the power rh. So right, limit h tends to 0, h. So right, e to the power h plus e to the power 2h plus e to the power 3h plus right e to the power nh. Now children, let's look at here. Few students write like that. Don't write. This is wrong. So they are writing here no. Just write e to the power h like that written. So don't write. This is wrong. Understood? Summation sum. First one, then put 2, then 3 put, then 4 is like that. So now write here limit h tends to 0. H, take e to the power h common, 1 plus e to the power h, e to the power 2h plus right e to the power n minus 1 into h. Okay. Now the formula all of you know, limit h tends to 0, h e to the power h e to the power nh minus 1 by e to the power h minus 1. Okay. Now value of nh you know 1. Okay, so right, limit h tends to 0, h by e to the power h minus 1 into, right here e to the power h here it will be 0, h tends to 0, okay, e to the power 0, 1, and this part will be e to the e minus 1, nh value is 1, so this is 1, limit value 1, so answer is e minus 1, this is the answer. Okay. Simply just write e to the power x, e to the power x dx, only this will be e to the power x, this part, simple formula. Okay, so e to the power x, so write 0 to 1, that is e minus e0 1, e minus 1. So with the help of first principle of definite integral. Okay, no more today. Again next I will discuss few sums, very important sums also there. Okay, bye.